In this video, we're going to learn how to solve a polynomial equation. So the first step is to use something called the rational zero theorem to make a list of all of your potential rational zeros. And in order to do this, we're going to describe our possible rational zeros as P over Q, and we're going to consider both positive and negative factors in each case. So your P values in this case, they come from your constant of the original polynomial. So I want all the factors of 4. So I know 1 and 4 are both factors of 4, as well as 2 times itself. So we only list the 2 twice. And then your Q values, those are going to come from your leading coefficient. So you do have to make sure that your terms are in order from highest power of x down to lowest power of x. And so again, my factors of 4 for my leading coefficient are going to also be 1, 2, and 4. Now, to make our actual list of potential zeros, of course we have a plus or minus because we consider both positive and negative. We take every number on top and we're going to combine it with every number on bottom. So I'll start with putting everything over 1. So 1 over 1 would be 1, 2 over 1 would be 2, and 4 over 1 would be 4. So I have 1, 2, and 4 at that point. Then I'm going to go back and I'm going to put every number over 2. So when I do 1 over 2, that would be a half. When I put 2 over 2, that would reduce to 1, and I already have 1 listed, so don't list it again. When I do 4 over 2, that would reduce to a 2, so don't list that again. So then finally, I go back, and I'm going to put all of the numbers over 4. So when I do 1 over 4, that's going to give me the fraction 1/4. When I do 2 over 4, that reduces to a half, which is already listed. And when I do 4 over 4, that reduces to 1. So every number on top gets combined with every number on bottom, and that is how you make your list of potential zeros. Now, we are going to be referring to the actual graph to get at least one zero that we can see on the graph. You can't necessarily see them all because, especially if they are irrational, we can't estimate those just by looking. But we will be able to see at least one that is exact. And so what I notice here is I notice that there is a 0 that's crossing at 4. So we're going to use that 0, since we know it exists, to set up our synthetic division so that we can find the other zeros of the polynomial. Remember, with synthetic division, you're going to bring down these coefficients. So again, you have to make sure they are in order. So we have a 4, negative 21, positive 21, and negative 4. And then carry out your synthetic division. So the 4 comes straight down. We multiply by the box. 4 times 4 is 16. When we add, we get negative 5. Multiply by the box. Negative 5 times 4 is negative 20. When we add, we get 1. Multiply by the box. 1 times 4 is 4. And when we add, we get 0. Remember, if you don't get this 0 in that final column, you have either not read the graph correctly to identify the 0, or you've made a sign mistake somewhere. So we definitely know x equals 4 is one of our solutions. We see it, and we got the 0 over here. Now, our depressed polynomial, since this started out as 4x cubed, we now have 4x squared minus 5x plus 1. And we can do one of two things. We can try to factor that, or actually one of three things. We can try to factor it as is. We could use the quadratic formula if we wanted, or we could go back to the graph and see if there is a second 0 that we can identify. And what I notice right here when I am looking is it appears that the graph is crossing at x is equal to 1. So we can use that second identified 0 and our coefficients off of our depressed polynomial and carry out synthetic division again. So bring my 4 straight down. 4 times 1 is 4. When I add, I get negative 1. Negative 1 times 1 is negative 1. And when I add, I get 0. So that definitely confirms that x equal 1 is also a solution. Now, if we look at our new coefficient, since this was 4x squared, this is now just a 4x minus 1. So to find that final 0 that is kind of hard to just identify on the graph, we set the remaining factor 4x minus 1 equal to 0 and we solve it. So if I add 1 on both sides, 4x is equal to 1, and then divide both sides by 4, I get my final solution, x is equal to 1/4. And that's what we're seeing over here, where the graph is crossing right there. Also notice if we go back to our list, in our list we did have a positive 1, we did have a positive 4, and we also had a positive 1/4. So as long as they're rational, they will appear in that list.